We're going to examine how R stores information in a variable. When that information is stored in the variable, that type of information is called the data type. And it's important to understand the data types because it determines how much memory is actually used by the particular variable. For larger complex programs, this is more important. For small scripts or working with small data sets, this is not much of an issue. R has 6 primary atomic data types, and an atomic data type is a base level or the most low-level type of data that you can have. R has character, which consists of letters and numbers or a mixture of such to create things we would know as strings. Numeric data types, which would have numbers that are decimal points or even potentially whole numbers, but you would have a 0.0 at the end. Integers, which are true whole numbers where there is no decimal point. Logical, which will be true and false, which is represented as true and false Boolean in R, but can also be represented as a capital T or a capital F. Please note that true and false the T must be capitalized or the F must be capitalized even when you write out the whole word. Complex data types, which are numbers that include imaginary numbers represented by the letter I. These would be used in physics or in some other type of differential equations. And raw, which is used for raw bytes. For the purposes of this module, we will not be discussing complex and raw data types. Now, we can have a little bit more complicated data structures, which will hold more than one value. So what we talked about before were variables that hold a single value. However, sometimes we need to hold multiple values, and it's preferable to hold them in the same variable. So R has 5 primary data structures. One is a vector, which is an array of values, so they will be the same, like character or numeric. We can have 100 or 200 or 300. A list, which is an ordered sequence of objects in which each object can be of any data type in the data structure. And we'll see more of that later, but it would be like having the first element of a list being an integer, the second element of a list being a vector, the third element of the list being another integer, and the fourth element of the list being another vector. So it's variable in size and data type. A matrix, which is a 2-dimensional array of the same basic data type, and this is important for a lot of calculations when you deal with things like covariance matrices or when you're doing matrix multiplication in linear algebra. A data frame, which you'd be familiar with if you remember in Excel, we have our worksheets. It's a 2-dimensional construct with rows and columns, but each column can be a different basic data type. So you can have like if you consider a worksheet in Excel, you would have multiple rows and each column could be a different data type. One could be a character string of a person's name, first name, let's say another column for last name, another one for grade, and so forth. And finally, a factor, which creates a classification or group of similar values. So in this case, you might have some character strings, but they need to be represented internally as numerics if you're going to do, and we'll talk about this when we get into the sections of regression for dummy variables. So what it does is it creates 3 levels in this example of New York City, LA, and Chicago. And it can represent numerical values for computations. Now, there are some special values in R. One is NA, which is a missing value or not available. So those are important because you're going to get data that you import and you're going to analyze, and you need to know which ones are missing. So it's an easy way to find which ones are missing. And then you can also have R automatically remove them if necessary. So while not really numbers, R does have some key words that represent certain types of values, like NaN, which is not a number. And it occurs when the calculation is not valid, like division by 0. We also have positive infinity and negative infinity, INF and negative INF. So, for example, in some cases, 1 divided by 0 will actually yield INF. Everything larger than the predetermined largest value and smallest value, R will consider INF and negative INF. And this value is approximately 1.8 times 10 to the 308th power.